Thank you and good evening also Bani. And this is a joint work with Michela and Gnaldi from University of Perugia. And I'm going to talk about differential item functioning applied to INVALSI tests using the item response theory framework. Okay, let's start with the definition of this phenomenon. Differential item functioning, diff for short, is something that occurs to a specific item, and it happens whenever subjects belonging to different groups but with the same level of ability have a different probability to respond to correct response to this item. And often groups are defined according to gender, ethnicity, and geographic location, and at least we need two groups, generally called as reference group and focal group. And this is the definition using a formula that is the probability, the conditional probability of response given the same ability level denoted by theta in this case is different when the group is the reference group with respect to the focal group. Okay, it is important to underline that if differences occur between these two groups occur due to the difference in the ability, that this is not diff, okay, because the procedure for detecting diff needs a matching of individuals according to the same level of ability. So diff analysis is performed within groups of subjects with the same level of ability. We can have two types of diff, uniform and non-uniform, according to the dependence of the differences on the ability level. This is an example of uniform diff. This is the conditional response function as a function of the ability, and as you can see in this case, in the uniform diff, one curve is always above the other, okay, regardless of the level of the ability. While in case of non-uniform diff, these two curves cross each other, and for example, for low level of ability, the focal group is above the reference, while for high level of ability, the reference group is above the focal group. We have two types of detection methods, basically related to the framework. We have classic methods that use the raw test score as matching variable. For example, the Mantel-Haenszel test, SIP test, logistic regression approach. While the other type of methods are rely on IRT model, item response theory, and then in this case the matching variable is the estimate of the latent rate as proxy of the student's ability. We have many types of methods, loss test, ratio test, or IRT based likelihood ratio test, and so on. Very quickly, Mantel-Haenszel test is based on the analysis of contingency tables, while the logistic regression approach considers different types of logistic regression models by setting specific covariates. While the IRT-based methods are, of course, based on the item response theory framework, in which the conditional response probability is modeled as a function of item features such as the difficulty and the discrimination, and also this conditional probability is modeled as a function of student characteristic. I here used unique within parentheses because the characteristic of a student can be unique, that is, the ability can be a unidimensional concept, or can be a multidimensional construct. So we have several sub-abilities potentially related to each other. Okay, these are these two methods we have considered in this work. Loss test basically compare the differences between item parameters, while the IRT-based likely ratio test compare two nested models. The first one is a model in which the parameters, the item parameters, are identical for both groups. And then another model which is called augmented model, where the parameters for the suspected item are left free to vary over the two groups. Okay, we considered INVALSI test data on mathematics administered in 2019 to students of grade 5. Sample classes, so we have almost 25,000 students, and the test at issue has 39 items classified according to the usual schemes, let's say, contents, cognitive processes, the macro dimensions of national indications. And this is the setting of our work. We for the moment consider the gender the potential causes of diff. We use more stringent cutoff value for the p-value, which is 1% rather than the 5%. And in this case we are fitting a rush model, so we are able to assess only the uniform diff. This is a slide only to show you the classification of the items according to, in particular, to these three macro dimensions, because we use this setting for the multidimensional setting. And okay, diff assessment is performed for each item separately. So we are going to perform 39 different tests. So for each item we have a test statistic, okay? We have the p-value associated to the statistic, and then we have to decide whether the item is or not affected by diff according to the p-value. We decide to look at the agreement between methods. And as you can see, classic methods, that is methods based on the raw score, show a perfect agreement, okay? Because all the elements are on the main diagonal. So for the final decision according to these methods, I perfectly agree. Even if the size, the magnitude of diff can be labeled as negligible for these 30 items. Again, for the IRT-based methods, we have again a perfect, almost perfect agreement. Only for one item we have a disagree. And again, we can observe almost perfect agreement between classic methods and IRT-based methods. For except only these two items, and only one item here. But the problem we want to highlight is the following, because we can consider the ability as a multidimensional construct. This means that the student's ability is made of several and potentially related dimensions, and from a statistical point of view, this means that we have to use a multivariate random variable. And of course, this assumption has an important effect on the detection procedure, because the matching procedure is made of considering the estimate of the latent rate. So if we use a unidimensional model rather than the unidimensional model, things can change. And in particular, we are used the multidimensional structure based on the initial indication. So we have 3 dimensions, and the first result is about simply model comparison between the unidimensional IRT model versus the multidimensional using the Rush parameterization. And according to the AIC or the BIC, or a simple likelihood ratio test, we can observe that the multidimensional model has a better fitting on this data. So we can use this multidimensional model. And these are the results about the agreement about the diff detection of the items according to these 2 methods, which are all based on the item response theory framework, but one is multidimensional and one is unidimensional. Okay, marginally speaking, there is quite agreement, okay, because 29 items are detected as diff according to the unidimensional model, 28 are detected as diff for the multidimensional method. But the problem is in the joint frequency, because we can observe a disagreement in 11 items. That is almost 30% of the test. And in particular, these are the details of the 11 disagreeing items. This means that for these items, one method detects as for example, for these first 6 items, the multidimensional IRT method does not detect diff for this item, while the unidimensional does. And the other end, we have the following for these 5 items. But another point to discuss is that all the 4 items within the reasoning dimension are in this set. Maybe we can work on the reason for this, but for the moment we have to better investigate on this point. Okay, the first step of the analysis could stop here, because we have analyzed the agreement between methods based on different assumptions, but we can go on and look at let's say, the magnitude of the differential item functioning for the items. So we can start from, for example, using the multidimensional model, and then, okay, we have these 11 items, okay, that don't show diff. Okay, so we start with this item and we label this item as anchor items. So we restart the entire procedure, that is the sequence of a likelihood ratio test, by using these 2 types of model. A baseline model in which the parameters for these anchor items are constrained to be equal over the 2 groups, and in this case is male and female. And then we can test again whether the parameters for non-anchor items are equal, one by one. So in this case, we are testing whether the items that were initially detected as diff still exhibit diff after using these 11 items as anchor items. Then this procedure is repeated until anchor items are no longer detected. At the end, we have these results. This is the table, so many numbers also here, sorry, but we have the difficulty parameter because we have a rush model for each item, and the item in boldface are the items that don't exhibit diff. We have 25 items at the end, while the other one have diff, and the magnitude of diff can be obtained as the differences with the difference between these two difficulties for each item. Okay, last slide. We have many points to discuss because this work can be enlarged in several directions. For example, we can consider a different multidimensional structure for the data. For example, by considering the contents and the cognitive processes, or we can consider different grouping variables such as ethnicity, geographic area. We can consider a different parameterization for the model. Then we can relax the assumption of equal discrimination among items, and then in this case we can use a 2PL parameterization, and then we are able to investigate also non-uniform diff. Again, we can consider this differential test function. So if we have some items affected by diff, we can verify if these items as a whole also affect the entire test in terms of unfair test, let's say. Last but not the least, this is a problem when testing several statistical hypotheses, that is the multiple comparison problem, because in this case we are testing several hypotheses at the same time. So we need to adjust the p-value for taking into account this problem. Thank you very much.